Hello guys, welcome back to our YouTube channel. Myself 𝗍𝗲, and today we are going to solve problems from CodeChef Starters 201. Okay, without wasting any time, let us get started.
Okay, so let us start with our first problem. So the problem name is selling coins. Okay, so let us see the problem statement. Chef has a number of silver coins and B number of gold coins. Okay, so he can do the following two things. One is if he sell a silver coin. Okay, if he sells a silver coin, he will get, let's assume if he sells one silver coin, then he will get 1 rupee. Okay, whereas he can exchange one gold coin. If he exchange one gold coin, then he will get two silver coins. Okay, so in this, these are the two things that HF can do. So he has a number of silver coins and B number of gold coins. So in total, Chef is trying to sell his coins and earn as much money as possible. Now you need to tell me that how much money can he earn by selling the silver coins and gold coins. Okay, so let us see the sample input and output. So in the first test case, Chef has two number of silver coins and one gold coin. So if Chef is trying to sell two number of silver coin, then he will get 2 rupees because one silver coin is giving him 1 rupee. Okay. So now if he sells one gold coin, then he will get two silver coins. So again, if he sells these two silver coins, then how much money do he get? He will get 2 rupees. So in total, what is 2 plus 2 is nothing but 4. So this is the sample input 1. Now let us look at the sample input 2. So Chef is having 10 silver coins. So if he sell these 10 silver coins, he will get 10 rupees, right? Now again he has 10 gold coins. If he exchange 10 gold coins, he will get 20 silver coins. And now if he sells 20 silver coins, he will get 20 rupees. As simple as that. So in total, what is the amount of money that a chef is able to earn? 30 rupees, right? So this is the expected input and output. I think the question is pretty much easy. There is no need of discussions. So the answer is also simple, right? So how many silver coins he has? He will simply print that, which is nothing but S is nothing but silver coins, and he has G number of gold coins. So each gold coin will give him two silver coins. So can I say G into 2? So he will simply print this one, right? He will simply print this. So without wasting any time, let us run the code. Okay, so how many inputs are there? There are only two inputs. One is silver and one is gold, right? So let us take the input of silver and let us take the input of gold. Each silver coin will give him only 1 rupee. So we will simply print silver as it is. But whereas gold will give him 2 rupees, right? So here you will simply print gold into 2. That's it. This is the code. Now let us run the code. Submit. It will work. Okay. Without wasting any time, let us go to the next problem. So let us look at the next problem. So the problem name is mixing liquids. Okay. So let us see what is the problem statement. Chef is now making an orange juice and he has A units of orange syrup and B units of water. Okay. So to make an orange juice, he needs to mix at least 1 unit of orange syrup and 2 units of water so that he can make an orange juice. Okay. So basically chef is having an orange syrup and some amount of water. So if he combines these two things, then only he will be able to make an orange juice. So he follows a specific ratio to make an orange juice. That is nothing but 1:2 ratio. So what is this 1:2 ratio is? In the glass, that in the orange juice that he is trying to make, it should have at least 1 unit of orange juice and 2 units of water. This will give him an orange juice. Okay. So the problem statement boils down to a simple words, something like this. So you are given multiple test cases. For each test case, you are given two things. One is the syrup quantity, okay, or let us call it as A. A is nothing but syrup, and B is nothing but the amount of water that he has. Okay, so by using these two things, you need to tell me how much oranges can the chef makes. Okay, for example, if the take the first test case, which is 1,5. It's nothing but chef is having 1 unit of orange syrup and 5 units of water. So how much units of orange juice can he make? Let us see. Let us go one by one iteration. In the first iteration, we will follow 1:2 ratio, which is nothing but we will use 1 unit of orange juice, orange syrup, which turns out to be 0, and B, we will take 2 units of water from the 5 units. Okay, so this one boils down to, so how much units of oranges did we made just now? We made 3 units. How? 1 unit of orange syrup plus 2 units of water is nothing but 3 units. Now let us have a second iteration. In the second time, can the chef make an orange juice with the orange syrup that he has and the water that he has? No. Why? Because there is no orange syrup left, right? So can I say, for the first test case, the amount of oranges that the chef can make is 3 units. Okay. Now let us go for the second test case, A, comma B, where A is nothing but 5. He has 5 units of orange syrup and 5 units of water. Let us see how much orange juice can the chef makes. So in the first iteration, he will take 1 unit of orange syrup from the 5 units. This boils down to 4, and 2 units of water from the 5 units that he has. This boils down to 3. So in the first iteration, he made 3 units, right? Now let us go for the second iteration. Can he make an orange juice? Yes. Here orange syrup boils down to 3 and orange water boils down to 1. Here he can make 3 units of oranges again. Let us go for one more iteration. So in the iteration 3, he has the orange syrup, which is nothing but he will simply take 1 unit of orange syrup from the 3 units that he has. But he take 2 units of water from the 1 unit that he has? No. So in this case, we cannot produce one more glass of orange juice in the third iteration. So how many units of orange juice did the chef produce it till now? 3 plus 3 is nothing but 6. So in total, he made 6 units of orange juice, okay, from the values of 5, 5. Now let us go for 10, 1. 10, 1. Here it is not possible because he follows 1:2 ratio, but he has only 1 unit of water, but he needs to have at least 2 units of water. So in this case, it is not possible. Okay. So I think the question is pretty much simple. So let us see the constraints. The constraints are also very small. So we can simply write a brute force code for this, right? So without wasting any time, let us write the brute force code. Okay, so let us write the code for this. So what does the input format looks like? We need to take the number of test cases first. So let us take the test cases, and there are 2 inputs for each test case, A comma B. So let us take A and B. Now what do we need to do? Since the constraints are very small, we will simply write a brute force code. So let us declare a variable count equal to 0, which will hold the maximum amount of orange juice that the chef can use, that the chef will make. Okay. So here what we can do is he needs to have at least 1 unit of orange syrup, right? So here we will simply write a condition something like this: A is greater than or equal to 1 and B is greater than or equal to 2, because if he wants to make at least 1 unit of orange juice, then he needs to have at least 1 unit of orange syrup and 2 units of water. So that is why we have put the condition as A is greater than or equal to 1 and B is greater than or equal to 2. Okay. So at each iteration, he will make 3 units of orange syrup, and therefore he will decrement A value by 1 and B value by 2. That's it. Now after this is done, you will simply print the count, cout count. Okay. Now let us run the code. 6, and that is the expected output for 5, 5. It is submitted. Okay. Without wasting any time, let us go for the next problem. Okay, now let us go for the next problem. So the problem name is mark points. Okay, so let us see what is the problem statement. So there are n equal spacing numbers from 1 to n. Okay, and in one operation you can choose x. Okay, if you choose x, okay, then you need to mark x as pointed, like marked, and you need to mark x, and then you need to mark x minus 1, and then you need to mark x plus 1. Okay, now if you see here, the condition that he has placed is that you can only choose from 2 to n minus 1. Okay, why? For example, let's say you have 1, 2, 3, 4, 5. If I choose x as 3, then I can mark this one, I can mark 2, I can mark 4, right? But whereas if I choose x value as 1, I can mark 1, I can mark 2, which is x plus 1, but there is no x minus 1 value, right? So that is why he mentioned that whatever x value that you are choosing, it should be within the range from 2 to n minus 1. You cannot choose the first value, you cannot choose the last value. Okay, now so if any one of the value is marked, then you need to make it as, if any one of the value is unmarked, then you need to simply mark it. Okay, so once you perform this operation, okay, in one operation you can select any x value, you need to mark x, x minus 1, x plus 1. Okay, even if it is not marked, even if it is marked, we can simply mark it. Okay, there is no toggle issues here. Okay, now finally, you will make a binary string where s of I is equal to 1 if and only if you have marked point I. Okay, you will understand this when we are explaining the test cases. Okay, now you forgot what operations did. Now you will forgot what operations you did. You have a binary string s with you. Okay, you want to check if it is possible to obtain the s by doing some of the above operations by marking the points. Okay, now if you see the problem, if you see the test cases, so in the first test case you are given 0 0 0. Okay, now what did he mention? Finally you will make a notice this. Okay, s of I is equal to 1. What is the meaning of s of I is equal to 1? If and only if you have marked that point. Okay, now let's say n value is 3, right? Now let's assume you have 1, 2 and 3. So here all the values are 0. What does that mean? What does that mean? You have not even marked a single x value. You have not even marked any value. So can I say you can obtain, you can get this result by not marking any value? Yes. So that is why the answer is yes. Now let us take the next one, second test case. This is the first test case. Now let us go for the second test case. 1 1 1 1. Okay, now let us say the size of the string is 4, so which means we will have 1 2 3 and 4. Okay, now how do we obtain, how? So here I have all the values as 1. What does that mean? You have successfully marked each and every value from 1 to 4. So how can I mark all the values? Let us see. I cannot choose this value, I cannot choose this value, right? So the only values I can choose is 2 comma 3. So if I take the x value as 3, then I will mark 2, I will mark 1, I will mark 3. Okay, now again I will take my x value as 3 here. Okay, if I take the x value as 3, I will mark 3, I will mark 2, I will mark 4. Now finally all the values are marked, right? So can I say if I mark all the values, then this is the result that I can get. So am I able to achieve this binary string? Yes. So that is why the answer is yes. Okay, now the next one is 0 0 1 0 1. Okay, 0 0 1 0 1. So which means I have 1 2 3 4 5 values. Can I able to get, can I able to obtain this binary string? Let us see. So if you see here, these two values are only the elements which are marked. But is that possible? Is that possible? Whatever element that you select, let's assume that I have taken this x value as 2. If I take the x value as 2, I will mark this, I will mark this, I will mark this. The final binary representation that I will get is 1 1 1 0 0. But this is not my answer, right? So I cannot choose x value as 2. Okay, can I choose the x value as 3? If I choose the x value as 3, then the final result that I will get is I can mark 3, I can mark 4, I can mark 2. The binary number that I will get is 0 1 1 1 0. But again, this is not the expected output, right? I need to somehow obtain this binary string, but I am unable to get that. Okay, let us try for 4. If you try for 4, you will mark this one, you will mark this one, you will mark this one. The final binary string is 0 0 triple ones, but this is not the expected output either. So one thing you need to observe is if you select any value, definitely you will get three consecutive ones because you are marking x, you are marking x minus 1, you are marking x plus 1, which will give you three consecutive ones. But here there are no three consecutive ones. Okay, there are two ones which are separated by a 0. So this is not at all possible, right? This is not at all possible. So in this case, the answer is a no. Okay, now let us try the next one. Again, here also, if you see here, you have three consecutive ones. Yes, if you select this one, you can mark this, you can mark this, you can mark this. But here there are only two consecutive ones, but that is not at all possible, right? Again, the answer is a no here. Now what about here? Again, three consecutive ones, three consecutive ones, three consecutive ones. Then therefore the answer is a yes here. Okay. Now what about here? Only two ones. It is not at all possible, which is a no. Again here, two ones, which is a no. So one key observation that you need to make is, if I pick one x value, I will be able to mark x minus 1, x and x plus 1, which will for sure will give you at least minimum of three consecutive ones. Maximum it can be anything. Okay. So this is the question, guys. Again, what is the logic for this? But before I give, we have discussed all these test cases. Now let me give you one simple test case. Let's assume the binary string is something like this: 1 1 1 1 1 and two zeros. Is this possible? Let us see. Let us see. You have 1 2 3 4 5 6 and 7. So let us pick one value. Let us pick x value as 3. If you pick x value as 3, then you can mark this, this, this. Done. But there are two ones that are left, two elements that I need to mark. So in order to mark this value, I need to pick x value as 4. If I take this, I will mark this, this and this. If I pick the x value as this 2, I will be able to mark this, this and this. So in total I have marked all the elements. Therefore the binary string that I will get is 1 1 1 1 and 0 0. Okay. Now did you observe anything? If some element is marked, I am marking it again. It doesn't matter because in the question he did not mention something like, if you mark any value, then you should not mark the same value again. He did not mention. That is why the problem becomes very easy for us. Okay. So what do we do? What is the logic for this? How do we come up with a logic? Again, the logic is pretty much simple. So okay, so what is the logic? The logic is pretty much simple. So if you see here, let us take one test case, all ones. Okay, all ones. So the given string is, this is the given string, 1 1 1 1. Let us take one more one. Okay, now what will I do? I will clone the same string to another string. Okay, I will create one more string and I will store the same binary values here as well. Okay, now here what I will do is I will run my for loop from I equal to 1, which is 0 based indexing, to n minus 1 till here. Okay, so here what I will do is I will simply compare, is my ith position is equal to 1? Yes. Is my I minus 1 position is equal to 1? Yes. Is my I plus 1 position is equal to 1? Yes. All these values are 1. So what will I do? I will simply mark this one as 0, this one as 0 and this one as 0 in the temporary string, but not in the given string. Okay. Now this is completed. Let us go to the next index. Now again, current position is 1, previous position is 1, the next position is also 1. So again, what will I do? I will simply mark this one, this one, this one in my temporary string. Okay. Now I will simply move the I value to the next position. Okay. Here again, the current value is 1, next value is 1, previous value is 1. So I will simply mark this one as 0, this one as 0, this one as 0 in my temporary string. Now how do I know whether I can obtain this result or not? You can simply look into your temporary string. If you see, you need to simply check, is every index turned to 0 or not? Is every index turned to 0 or not? Here Yes, every index is turned to 0. So what is 0 is indicating? 0 is indicating that you have successfully marked. You have successfully marked. So here there is no 1 in my temporary string. So I can say that the answer is a yes. Now let us take one more test case. 1, 1, 1, 0, 1, 0, 1, 0. Am I able to mark this? No, because you cannot generate something like this. Two ones separated by a 0. Okay, let us. I will clone this into my temporary string. Okay, 1, 1, 1, 0, 1, 0, 1, 0. Now, again, this is 1, previous element is 1, next element is 1. So I will simply toggle this to 0, 0, 0. Okay, now this is 1, previous is 1, but the next value is not 1. So I cannot toggle. Here I cannot toggle. Here I cannot toggle. So I am done with my iteration. But if you see the temporary string, are you able to find any ones in the temporary string? Yes. Which means, can I say, is it impossible to toggle these two characters? Yes. So the answer is a no for this. Okay. So this is the logic, guys. Now without wasting any time, let us write the code for this. Okay. Now let us see the input format. First, you need to have t number of test cases. So let us take the number of test cases. Now what else? You will be given the size of the string. Okay. Now take the size of the string and as well as the size, like the string, and you will make a temporary string as well. Your t's will be pointing to s. Now what is next? So we will hold one variable. Result is equal to true initially. Okay. Now what will I do? I will run a for loop from I equal to 1 till I less than n minus 1 I plus plus. Okay. Now I will simply check if s of I is equal to 1 and s of I minus 1 is equal to 1 and s of I plus 1 is equal to 1. If this is true, what do I need to do? I need to toggle in the temporary string but not in the original string. T of I is equal to, T of I is equal to 0 and T of I plus 1 is equal to 0, T of I minus 1 is equal to 0. Okay, that's it. Now, what do you need to do? You will simply iterate on the temporary string now. You will simply iterate on the temporary string. If the temporary string has at least any 1, then I will simply make my result as false. I will simply break from here. Okay. Now here I will simply check if the result is true. Cout s, cout capital Y, or no. Simply print no as the answer. That's it. Now let us run the code. Yes, yes, no, no, yes, no. It got submitted. Okay, now let us go for the next problem. Okay, now let us move on to the next problem. So the problem name is huge grid. Okay, huge grid. So this is an easy version of the problem. There is also a hard version which is in the last problem. So let us see the problem statement. Given a binary sequence A of length n, construct a matrix of n cross n B matrix as follows. Okay. So if you see the constraints, you basically know matrix, right? A matrix follows two-way indexing. You need to have at least two indices, like 0, 0, 0, 1, and then 1, 0. So in this case, whatever indexing that you select, if I is less than or equal to j, then you need to simply, let's assume that there is an array. So you need to simply get the sum from index I to the index j. You need to store this sum at the index of I comma j. If and only if I is less than or equal to j. If I is greater than j, then whatever matrix that you have constructed previously, you can simply get the opposite of it. If I is greater than j, then you need to get the sum of b of j comma I. You don't need to construct any other matrix, any other sum from this. Okay. So this is the condition. Now, define a path from 1 comma 1 to n comma n as a sequence of pairs. So basically when you construct any matrix, you have 0 comma 0, 0 comma 1, 1 comma, sorry, 0 comma 2, 1 comma 0, 1 comma 1, 1 comma 2, and so on, right? So each pair will hold a value, either a sum or a value from the opposite indexing. Okay, so this is nothing but I will explain. So basically you will be given a binary sequence. You will be given a sequence which is of zeros and ones. Okay, so from these zeros and ones you need to create a matrix. Let's assume the matrix is nothing but a cost matrix. You need to create a cost matrix. Okay, so in this cost matrix, after creating the cost matrix, what you need to do is you need to go from 0 comma 0 to n minus 1 comma n minus 1. This is always going to be a square matrix. Okay, so you need to go from 0 to 0 to n minus 1 comma n minus 1. So what do I mean by go? So every index will hold a value, something like 10, 4, no, not minus 10, 2, 1, something like this. Every index will have a value after performing this operation at every index. Okay, now what you need to do is you need to find a path which will take the minimum cost. You need to find a path which will take the minimum path sum. Okay, let's say if you are going from here to last index, something like this path is giving you a cost of 50. Or let's say if I go like this cost is giving me a cost of 10, then what is the minimum path? This one. So the sum of from the path sum should be small. Okay, so here I got 10, which is the least path sum that I can get, so you will simply print 10 as your answer. So this is the overall question. Okay, so what is the basic solution for this? What is the very basic solution? So first let us see how does this matrix conversion happens from the given binary number. So if you see from 0, 1, 1, which is the length of the 3, you need to create a matrix. Okay, so the matrix looks something like this. How did he get this matrix? I will explain. So the matrix that he has generated is 0, 1, 2, 1, 1, 2, and 2, 2, 1. So every matrix has indices, right? So let us write the indices first. 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and 2, 0, 2, 1, 2, 2. So here is I is less than or equal to j. Yes. Then what is the sum from 0 to 0? Is nothing but 0 itself. So you will simply assign 0 here. So here I is less than or equal to j. What is the sum from index 0 to index 1? What is the sum from index 0 to index 1? Which is this, which is nothing but 1. Here I is less than or equal to j again. What is the sum from index 0 to index 2? 2. That is why you got 2 here. Now here 1 comma 0. I is not less than or equal to j. I is greater than j. So what is the opposite of 1 comma 0? Is nothing but 0 comma 1. So what value do you have at 0 comma 1? 1. So that is why you are storing 1 here. Okay. Now here 1 comma 1. It is equal. So here you will get sum as 1. Okay. Now 1 less than or equal to 2. So what is the sum of index 1 to 2 from the given array? 2. That is why you got 2 here. Here 2 is greater than 0. So opposite of 2 comma 0 is 0 comma 2. What value do we have at 0 comma 2? It's nothing but 2. That is why you are storing 2 here. Okay. Now next index is 2 comma 1. Again it is greater. So the flip bits is nothing but 1 comma 2. At 1 comma 2 what value do we have? 2. That is why you are storing 2 here. Okay. Next 2 comma 2. Both of them are equal. So the sum from index 2 to 2 is nothing but 1. That is why you have got a 1 here. Okay. So this is how you will generate a matrix. Okay. So first solution, which is the brute force solution, is nothing but first you will simply generate this matrix. Okay. Generate the matrix. Okay. Afterwards, what you can do is you can simply find the minimum cost path from index 0 to 0 to n minus 1 comma m minus 1. But Here, did I mention in which ways can we iterate? No, right? So here he mentioned that from any point, let's say I comma j is this. From I comma j, you can either go to the right cell. So if you want to go to the right cell, your indexing will change to I comma j plus 1. Or if you want to go to the bottom cell, then the indexing will change to I plus 1 to j. So these are the two ways that you can traverse from any cell. So from this cell you can go to the right cell or bottom cell. Again, from this cell you can go to the right cell or bottom cell. These are the only ways that you can traverse. Okay. So after generating the entire matrix, what you can do is you can simply use a BFS with the Q. Okay. You will simply try all the possible paths. You will simply try all the possible paths. Okay. This is one way. But if you see the constraints are very huge. I don't think I have here. Okay. The constraints, the n value can go till 10 to the power of 6. The constraints are very huge. So if you try this approach, the logic is correct, but you will get a time limit exceed, because generating the matrix and then iterate and trying out all the possible paths from 0 to 0 to n minus 1 comma n minus 1 will take a lot of time. Therefore, you will get a TLE. So how do we optimize this? So first we need to make some observations. So what are those observations? If you see here, the matrix is a symmetric matrix. Yes or no? The matrix is a symmetric matrix. So 0, 1, 2, 0, 1, 2, 1, 1, 2, 1, 1, 2, 2, 2, 1, 2, 2, 1. The same row is being assigned as the same column. So therefore it is a symmetric matrix. So therefore if you see any matrix as a symmetric matrix, then you don't need to try all the possible paths. You don't need to try all the possible paths. You just need to iterate on the upper matrix itself. You don't need the lower matrix. So neglecting these values has no issue with us. We will still be able to find the minimum path sum that we can, because if you're traveling from here to here, if you're traveling from here to here, both the path sum will give you the same result. And one more thing, whatever the minimum path sum is there, that path sum will always lie in the upper triangular matrix, and the same path sum will be present in the lower triangular matrix as well. So that is why okay, so that is why we will simply neglect the lower half. Okay, we don't care about the lower half. Let us assume that we don't have these at all. So now you can use the same approach, like generate the matrix and go from here to here in all possible paths. Yes, you can use the same approach, but again the time complexity will remain the same. You will still get TLU. Okay, because you are simply reducing the number of iterations, but the big O notation, the time complexity will remain the same. Okay, so how do we optimize this? So there is one key observation that you need to make, and that observation lies in the operations that you are trying to perform. Okay, now let us see. I is less than or equal to j, then this or else this. Let us see. Let me write here. If let me use. So the first operation is I is less than or equal to j, then you need to simply find the sum of an array from index I to j. This is the first operation. If I is greater than j, then simply get the value from the B matrix of j to I. Okay. So these are the two operations that he has given to us. Now think of it like this. You have a matrix. Something like this, and you have two options. One option is you traverse to the right side, you traverse to the bottom side. Now which one will you select? Traversing to the right side or traversing to the bottom side? So let us see. If you are traversing to the right side, let's say you are at I comma j. Okay, now if you want to go to the right side, then what will change? Your indexing will change to I comma j plus 1. Whereas if you traverse to the bottom cell, then what is the indexing change? Your indexing will change to I plus 1 comma j. Now if you see here, what is this I comma j plus 1 is really indicating? So your let's assume this is I and this is j. I comma j plus 1. So this is the, let us give you some values here. 0, 1, 2. This is the 0, right? You need to get the sum from index I to j. Now what about here? What about here? This is 1. So I will remain the same. I will be here, but j will increase. J will go to here. So can I say, let's say you have 10 elements here. Now if you choose the first operation, then you are adding one more element. So therefore the number of elements are increased by 1. Yes or no? Yes. Okay. Okay. Now let us go to the next one, second operation, which is traversing to the bottom cell. Now here, will I remain this at the same position? No, I will plus 1. So it will go to the next index. J will remain the same. J will be here. Okay. Now what did you observe here? J is remaining at the same position, and as well as how many elements are there? If from I to j there are 10 elements, in the first operation, okay, if I comma j are having 10 elements, then if you choose to traverse to the right side, then it becomes 11 elements. And if you choose to traverse to the bottom side, the number of elements are reduced by 1. 10 minus 1 is nothing but 9. So which one will you choose? And you know that all the elements are positive. All the elements are positive. So in this case, which one will you choose? Will you be choosing the traversing to the right side or traversing to the bottom side? You will always choose traversing to the bottom side because the number of elements are less. If the number of elements are less, the sum will always be less compared to the traversing to the right operation. So I understand this, but what is the exact logic here? The logic is simple. Whenever you can traverse to the bottom cell, you will traverse to the bottom cell. Okay. So we know that we don't want the lower triangular matrix. So in this case, if you go to the bottom cell, you will be falling in the lower triangular matrix. So that is why, lower matrix. So we don't want that. So you will simply go to the right. You will take this sum. Okay. Now can you go to the bottom cell from here? Yes, you can go to the bottom cell. Just simply go here. Now again, can I go to the bottom cell again? No. You have to go to the right cell. Okay, just go here. Now can you go to the bottom cell? Yes, then simply go here. Okay, can you go to the bottom cell? Yes, then simply go here. Whenever you have a chance to go to the bottom cell, you will simply go to the bottom cell. But whenever you don't have an option of going to the bottom cell, then only you will go to the right cell. So this is the entire logic of this question. But how do we, like, what is the solution exactly? Like, do we need to generate that matrix? No, you don't need to generate that matrix. So if you see here, take this. So here, what are we doing? Which path are we considering? We have this path, but this will give you an answer of more than 5. What is the answer? 5, right? Yes, 5. So because of this, we don't want that path. We will choose this path. This will give you 3 plus 2, 5, right? So let us see how can we get this. What you will do is, first you will take this 0th value into your answer. Okay. Let me erase this. First you will take this value, which is nothing but 0th value into your answer. Okay. Now plus, you need to go to the right side. So you need to take the sum from 0 to 1, which is nothing but sum of these two values. Okay. So let me write it in the matrix order only. Okay. 0 comma 0 plus, you need to take this pair. Okay. 0 comma 1 plus. Now from here, there is an option of going to the bottom cell. There is an option of going to the bottom cell. So therefore you will go to the bottom cell, which is nothing but 1 comma 1. Okay. Now what you will do? Now again, from here, can you go to the right cell? Yes, you can go to the right cell. So you will consider this sum. This will give you, what does that give you? 1 comma 2, right? Now again, here do you have an option of going to the bottom cell? Yes, you have an option of going to the bottom cell. What is the path that you will get to go to the bottom cell? Which is nothing but plus 2 comma 2. So are you noticing any pattern here? 0 comma 0, 1 comma 1, 2 comma 2, 0 to 1, 1 to 2, 2 to 2, right? So it is simple. First you will consider the same index I comma I plus. In the next iteration we will consider I minus 1, okay, I minus 1 comma I. That's it. This will always considers only that path that we have just seen now, which is nothing but you will always go to the bottom cell whenever it is possible. If not, you will go to the right and then to the bottom. Okay. So without wasting any time, let us write the code for this. Okay. Now if you see the input format, first you will be given number of test cases. So let us take the number of test cases. And after each test case, for each test case you will be given n, which is nothing but the number of values. Then what else? You will be given a string. Okay, let us take the string as input. Now you will be having an array of size n. So what I will do is I will convert the string to an integer array. Okay, I less than n, I plus plus. If s of I is equal to 1, then what will I do is I will make array of I as 1, or else simply array of I as 0. Okay. Now since the answer is going to be might be huge because we are dealing with a lot of numbers, but the numbers are binary, so I will simply use long int for safety purpose. So what will I do? Again I will simply iterate on the given string. So first 0 comma 0, how do I take that? It is simple, answer plus equal to array of I. Now what will I do? I will check if I plus 1 is less than n. Why do I need to check I plus 1 as less than n? Because this will fail only when you are in the last column. This will fail only when you are in the last column, right? If you are not in the last column, then you will always have an opportunity to iterate to the bottom cell, right? So answer plus equal to array of I plus array of I plus 1. Now here you can simply print console.log, see out answer 501. Okay, it is got submitted, and that's all for today's videos, and thank you for watching the video. Hope you have liked the content.
So that's all for today's video, guys. Hope you have liked the video, and if you have liked the video, please do subscribe and share. And if you want to learn coding in detail, please enroll to our Smart Coder course by Smart Interviews. Thank you for watching the video.